Hello. Good to see you again. Daniel Ospina, I'm head of Aragon Association, and today I have the pleasure to have with us Pietro Speroni. Pietro is a mathematician and an expert in social choice, as well as democracy, online democracy, voting system. And he's going to be giving a talk with us about Pareto Fronts and how we can use them for decentralized. Pietro, welcome. If you'd like to come onto stage.
Hello, am I on stage?
Yeah.
Okay, good. So let me share this Chrome tab. Okay. And present. Why is it so small? It's just as tiny.
Yeah. It's coming. Okay. It's coming well on the. It's coming well on the render. So.
Okay, so it's just. I mean, I have a micro here, but doesn't matter. So yes, and this is the second presentation I'm giving, and this is starting like lessons where I'm going deeper and deeper in. And the last time we were cut short because, because as always, I present so much, I prepare so much material, but then it's usually more than what I can actually present, especially if I into the that permit everybody to really understand. This background of two colors, you will see it does have a meaning, and we're going to enter into that. Look at everything. The first
Have we lost Pietro? It seems he's having small technical issues with his connection. Let me get him back on stage. Online events and Wi-Fi still these days, huh? Pietro is looking to join again the call. Bear with us, it will be a few minutes. 2 more minutes and we'll be back. He's just joining backstage now again. Sorry.
I'm sorry, what happened?
Hard to say. I think the connection dropped, but good to have you back. If you'd like, please, the space is yours. Let's continue.
Okay, where did we on?
The very beginning, you were only showing the introduction.
Oh, actually, I wasn't. Went all far away. So,
yeah, unfortunately, we lost you at the very. If you'd be so kind from the top.
Yes, sure. I need to share the in the Chrome tab. Okay. Is this? Can you see this? The slide? Voting a number.
Yeah,
okay,
we can
perfect.
see you.
So basically, what I was saying is that we started with voting a number, and before you didn't miss a lot. Basically, I was going repeating what I said on the previous lesson, so it really doesn't matter. You can just previous lesson and hear it. In fact, we could actually put a link over here later. But with voting a number, the point is that you can actually have people participate and as I said, vote a number, which really opens the possibility for DAO to answer a continuous to choose among a continuous possible answers instead of just a yes no, and this is an extremely important one. Of the application would be the Aragon court, where people have someone says there's a contract and there was according to someone a contract, and so they go to the court and the court have to decide if they have to be paid or not paid. And normally right now it's just a yes no question, but with the same computational cost, people could just vote directly how much people should be paid. So if the defender should be paid 100%, or it should be paid 0%, and all the money should go to the accuser, or anything in between. And this is actually way more efficient than first vote yes no and then vote with a second smooth. It actually includes the second one. So also remember something: when you're voting yes no, you tend to brain with your rationality. When you have a continuous, you tend to, because a continuous is impossible to handle with your rationality, you tend to vote with your guts. You tend to vote with your instinct. You tend to move the slide a certain point until you kind of feel it that is the right one. And so it's not really a lot of work for the participants to use this kind of smooth, because they will actually do it in a simpler way. It will feel more intuitive and simpler. So I would really suggest that the Aragon court uses voting. And of course, voting must be cheap. I mean, we're speaking about a few cents. You cannot have voting that costs a tenth of. So if this means to leave at the moment Ethereum, well, so be it. I mean, there's a lot of right now. So another thing where it can really be applied, voting a number, is on monetary policy. And right now, and the question could be, how many coins should this network print in the next month? Right now, cryptocurrencies, they come in different flavors. Either like Bitcoin, they have a very precise decision, a very precise rule, and they follow that rule on and on. Or they printed everything from the beginning, and and then and that's a little bit like a company maybe. then or they could have something like where they preprint something and then they print the next one, and so on. Or sometimes they are not very decentralized, and so they kind of print some and then later on decided to print some more. So basically we have two different options. We have a fixed monetary policy like the one from Bitcoin, where Satoshi Nakamoto decided for everybody else, or on the other side you could have the chief of the European Central Bank to decide how much has been needs to be printed, and so this is a variable but is centralized. Well, this actually gives the possibility, this voting a number, to have a variable but decentralized monetary policy, and this for what I know hasn't been used and applied anybody so far. So this is a really interesting possibility, and the question can be one or can be two. It can be how many coins should this network print, or but it also could be how many coins should this organization should this network, actually not organization, burn. Yeah. And or how many coins should this DAO burn? So this is I think a really interesting element. So, and this ends the lesson 1, and now we're going to go to lesson 2. So far we spoke about yes no question or voting a number. Another option is finding the answer among a finite set of alternatives. And we have already spoke a little bit about it when we were presenting Condorcet systems as a way to find this solution. But there is another here, a problem which is really, and that is above, and somehow needs to be resolved if you want to have a really decentralized autonomous organization. And that is, who chooses the alternative? Because in normal democracies, it's very difficult for someone to have a referendum. They can present, say, we should vote about this, at least in Italy, to the court, I think even to the constitutional court, before it's actually permitted to have a referendum. For proposals of law, you must be an MP in Italy, or you have to have so many votes and so on. In a DAO, who actually the right to present an alternative, to let the participants vote. And we should actually move this question from finding the answer among a finite set of alternatives to find the answer to an open question. So instead of should we do A or B or C or D, we could have a question like, what shall we do? Or how shall we reach this goal? Okay? And those two questions are really important. Those two questions are somehow complementary, and they require different strategies. So, and they to cover most of the questions that come up. Okay, most of the come up will either be a what question or a how question, and sometimes something might not be worded like a what or a how question, but when you look inside, you will actually see that it's really like it will still have the signature of a question or a how question. So what are those two type of question? The what question question like, what should we do? Where should we go? What should Italy do for its economy? What shall we do about this particular problem, about this problem? How should we, what should we invest in? It's not a how, it's a what. What should we invest in? On the other side, we have the how question. And the how question is, we have already decided what we should do, but now the question is, how should we actually do it? How should we solve this problem? How should we go there? Okay. And this is a very old division, and you can actually find it out in people not realizing this division. Sometimes make cartoons, make fun, and when you actually look or jokes, and when you actually look inside, the problem is that they were using those two types of questions. This is a wonderful cartoon which I think came out in the New York Times, and it says, these smug pilots have lost touch with regular passengers like us. Who thinks I should fly the plane? And of course the assumption is that he's not a pilot. So here we have a mixture, because flying a plane is an expertise, and so it's actually the answer to how should we fly to there? Well, first you need to take the cloche, and then you need to call to the tower, and then you need to ask for permission. All the things that a pilot needs to do to actually fly. But then you actually have the what question, and the what question is, okay, in this case is a where. Where shall we do? Where shall we go? And this is important, because the what question is like a more popular question. Anybody can participate in this question. Is the question that say, okay, what shall we actually do about it? What shall we do this evening? And so on. Whereas the how question is the technical question, and you need to be an expert to participate. And maybe you might be able, without being an expert, and the risk of expert humbling you by saying what you're saying is just nonsense. So if you're having you need someone at home you need a plumber at home, so you call a plumber and you said, please, I'd like to have a water tap room, and the plumber might say, okay, those are your options. We might have opened it up from the kitchen from there, or we might actually do it over there. So it gives the option. And then it's your turn that say, okay, let's go for this option. And of course, the plumber might say, this one will take longer and it will cost more, but it's actually better for this. And whereas this other one is, the kind of system that all of you have lived very, very often every time you called an expert into doing something. Expert in plumbing, in electricity, or in implementing eDemocracy. So this kind of difference between what and how appears in all sorts of places. I don't know if any of you have read old books about military, about sailing military. In the old times, on a boat, you have the captain and you had the pilot, and to drive the boat, to drive the ship was actually not the captain, it was the pilot. The captain would say, please go there. But the pilot might actually say, well, we cannot go direct because we run the risk of of sinking because there's some danger over there. So we need to actually go around. And in a situation that is very dangerous was the pilot who was in charge, because even if the captain might actually give orders, the person who actually had on the steering wheel is the pilot. So in a sense, the two positions are, the captain in theory was above the pilot, but the pilot in some situation have more power. Even if you look at an ancient book about war, like Sun Tzu, in Sun Tzu, he says you have the king and you have the general. And it's very clear, that the king is the what and the general is the how. And once, the king says, go and conquer that country, but then it's the general that decides how. And if the street is open and he can see the victory, he should not go back and ask the king. He should just go and grab it. So it's giving even more power to the how. But the really important is this difference between a what that decides where to go and a how that decides how to actually reach it. This happens also in a company. In a company, the person who is in charge of this of the decision of how to actually do things is the CEO, the chief executive officer. But the person who owns and who decides where to go is the owner or the owners, il padrone in Italian. And I wrote also the clients, because there are times where, the most smart thing is to ask for clients what do they actually want. But the way in which it works is the owner says, okay, this company should go over there. And the CEO says, okay, who should bring it there? You should bring it there. Okay, and what happens if I'm unable to bring it there? Substitute you. And what happens if instead I'm able to go over there? Well, then I give you some extra stock, some extra stocks or something like that. So this is classical division. And actually, I took this from a lesson from Emilio Tomasini, exactly on how it works a company with the owner and the CEO. And so the question is, what are the what and how in a DAO, and who should actually present the proposals on what, and who should vote, and who should present the proposal on a how, and who should vote. And I'm not going to now. Let's consider this part of your homework for next lesson. I mean, because now we have to move on. And let's go back to the what and how, because we've seen pretty clearly what is the difference between a what question, but we haven't spoke about how those questions actually are different and how they entail different method to reach the answer. So what question usually want many solutions? So what Italian economy? Ooh, so many things you need to do. What shall we do about Italian politics? Ooh, so many things to do. Whereas how questions are normally want one solution. So how shall we make this car work? How shall we fix the engine of? That's one solution. You're not going to side by two engines side by side. You're only going to put one solution. In the what, expertise does not matter very much. That is, as I said before, there is a feedback from the house saying, well, what you're actually saying is not actually possible. For example, I was watching a very interesting video on YouTube on putting solar panels in the Sahara Desert, and also that this brings. And so this is a what? Let's put a solar panel in the Sahara Desert. And then there is a how, an expert that says, no, sorry, this is economically not work. So in the what is very common to have one man, one vote, or it can be one stock, one vote, one cryptocurrency, one vote. In Dash is one master node, one vote, and so on. In the how question instead, this is really interesting. Usually, the vote is less. You can implement something that has votes, but really it's less important, because if you have one expert, even if it's a single one, and you and says no, this will not work, and it kind of convinces you, its weight should leverage up to the point that it should actually change the point of view of everybody else. And so we're going to see different system for this. In the what, timing is important. What do I mean by timing is important? I mean, because a lot of people can participate in what questions, you will always have someone that joins before and someone that joins later. And it's very important to set up the system so that people that join before are not unfairly favorated. There is not people that come later don't come at a handicap. And if you look at a lot of what systems around that, what shall we do with our website? And people can present their proposal. I don't know, interactive brokers, to say one. It has the classical website. Interactive brokers is one of the cheaper places where you can buy and sell stocks. It's not like Robinhood, but it's really good. And then it has another kind of forum where you can present proposals. But this is the fact. There are people present proposals at different times, and the longer a proposal is there, the more votes it will have gathered. So it's particularly unfair from this point of view, especially if the number of actually represent the importance, the probability that the thing is actually being implemented. And those solutions in the what usually don't build upon each other. They're not exclusive, but they're kind of independent, one respect to the other. On the how, on the side, you can have multiple solutions, but eventually you want to have one single solution, and then you are going to merge together those separate partial solution into one single solution. You might have someone that says, well, we might build an engine that has this and that, and the other one says, well, actually it would be better in this way, and then you join the two solutions at the same time. And what they have in common is that to build, to reach those what solution in a fair way, or this how solution in a fair way, building it one upon the other, Pareto Fronts are really useful. So what are Pareto Fronts? What are Pareto Fronts? Pareto Fronts are an amazing concept. And the first time I heard about Pareto Front, it was in 2004, and I was at a conference about artificial life, and I was presenting something about artificial chemistries, I think, and there was someone presenting an artificial intelligence system, and they were using Pareto Front to compare different artificial intelligence softwares, because some software, and it was artificial intelligence system playing chess, and you could have a chess player very good in the opening, and another one that is very good at the end game, and someone that is can be really good at the middle game, and so by using the Pareto Front, they were able to open up to compare all those artificial intelligence strategies without forcing that one would always dominate into the other. And the result of this was this process was much more optimal. And I was flabbergasted by this concept, but it took me 5 years to understand how to use it. So what are Pareto Fronts? Now, suppose that you want to buy a car. This is how Pareto Fronts are used in companies. Suppose that a company wants to buy a car, and they want it to be fast, and they want it not to consume a lot. So two different, ascisse ordinate, X and Y. And for each car, they say, okay, this is the speed of the car, and this is how many kilometers per liter it actually consumes. So this would probably be a Ferrari. And whereas this one would probably be something that doesn't consume very much, but it's kind of very slow. And this is some sort of a utilitarian, and something over here is probably my car, and which is very slow, but still manages to consume a lot, and so on. So if you take your hundreds of possible cars, and you put one somewhere to just plot every car in this graph. And then you take the Pareto Front. What does it mean? It means that then you start to filter out. Sometimes you can say that the car is absolutely better than one. When this is the case? Well, for example, this car is, I think you can see my mouse, right? Is absolutely better than this other one, because it's both faster and it consumes less. Also, this car is absolutely better than this other one, and this is absolutely better on this other one, and this car is absolutely better than this one, and this is absolutely better than this one. So, and you also have the transitive property. If this car, let's call it A, is better than this car, let's call it B, and B is better than this car C, then automatically the A car is better than C. Okay, so what is the definition of being better? We call it, in mathematics, we call it domination, and we say that a proposal dominates another one if on every dimension it is equal or better than proposal A dominates proposal B if proposal A is equal or better than B in every dimension. And then there is at least one dimension in which it's strictly better. So if they are exactly the same on everything, of course, not say that one dominates the other. But in one sense, it's better, and in everything else is the same, then it's better. And even more if it's better on all the various criteria. So it's both faster and consumes less. And so once you take away all the dominated proposal, you ignore them, you throw them away, you remain with a set of proposals. And you can take them away and just remain with this set of proposals. And this is a really good way of solving a problem where you have multiple systems and you actually need just to decide among a few systems. I've actually applied this quite recently. I was making some strategies of automatic trading, and if you do know something about automatic trading, you know that the parameters are really important. And so I wanted a strategy which was both it would let me gain a lot of money on one side, but it also would not make me lose too much money, make me risk too much money. And usually the more you are risking, the more you gain. So it's a little bit you gain on one side, is a little bit better on one side, but then is worse on the other side, and so on. So when I plotted all the graph, all the strategies, and I wrote a small Python program to bring out the Pareto front automatically, that was extremely simple. And could just watch the Pareto front, and I went from 200 or 300 different strategies, that is the same strategies with different parameters, to 4, 5. And at that point, I just picked those 4 or 5 and choose, by hand. And so the Pareto front will not give you the solution usually. It will give you a small set of solutions among which then you can do something else. So it's a filter. Now, you can apply it on everything. You can apply it on car. I want something which is fast and doesn't consume very much. You can apply it on a house. I want something which has low cost per square meter. High cost per square meter, which is worth a lot, but is also far away from the city center. No, I want the opposite. I want it low cost. I want a house that is cheap, but I also want it to be close to the city center. So you can just go over there, and for each car, calculate the distance, calculate how much does it cost per square meter, and easily you will find out all the values. You want to decide where to invest in crypto. You want something that is decentralized and it has a good technical development. And usually those are, the more centralized the easier it is often to have a technical development. The more decentralized it is, sometimes the more it's kind of left to itself. Ethereum Classic come to mind right now. I don't know exactly why. And on the stock, you have so many criteria. You can do price over earning. You can do discounted cash flow. You can do, how much are they paying? You can do a lot of things. The important thing is all those examples, I did it with 2 criteria, but you can have more than 2 criteria. You can have 3, 4, 5 criteria, and even infinite criteria. The problem is, the risk is that if you add many criteria, practically everything will end up being in the Pareto front. So you don't want to have that from happening. Now, there's a field that studies this, and for which Pareto front are really important, and where in that field where they speak about Pareto front, they don't explain what they are because they all know about it, and it's called multi-criteria decision making. Multi-criteria decision, MCDM also is the brief of. So if any of you is actually really interested about it, you can go on and search for that. And So multi-criteria decision making avoids the two errors that are two common errors that happen in the way you think. And one error is to think that everything is hierarchical. You have all the crypto coins. Oh, then all of them listed by market cap, and this coin is a fifth on market cap, and oh, your coin is only 50, or your coin is only 150, and so on. This is mixing apple and oranges. Another error is to say that nothing is hierarchical. To say, oh, we're all different. You never could say that one is better than the other. You cannot even give me a vote. You can even, I'm going to do an exam, but you are not even allowed to give me a vote because I'm so unique. And, both of those are not conducive to an optimal solution to reach to a path of improvement. But the math that studies those is very clear. I mean, in mathematics, you have fully ordered set on one side, you have unordered set on the other, and then in the middle between, like the cheese in a sandwich, you have partially ordered set, also known as poset. And so in the thinking everything is hierarchical, which are called the chains. Whereas in the thinking nothing is hierarchical, you actually have those set where you nothing. But in the poset, in the partially ordered, you have to say, okay, sometimes something is really better than something else. Not always, but and this is if you have to decide who works for you. Sometimes you can only employ one person. Some other times you ask for 10 people, and then and then you realize that some people are able to do, John is able to do everything that Andrew is able to do plus something, and it also asks for less money and whatever. So John is sure Andrew. No offense to any Andrew out there. But then you might have that John and Angie has totally different abilities, and even though you were thinking about only employing one, they actually have complementary abilities, and one is very good in designing nice user interface, and the other one is very good in the back end, and then and so on. So then you pick the front, and this and so the Pareto front is able to filter out all the suboptimal solutions and just reach few solutions. So let's go back to our question: who chooses the alternatives? The classical answer is that everybody should be able to choose the alternatives. The problem is that we risk having a combinatorial explosion. What is a combinatorial explosion? A combinatorial explosion is a situation where where you have a number of solutions, but then they can combine to each other and they build new solution, and this combines to each other and this builds a new solution, and so on until the number of solutions you need to handle with is explosive. You actually cannot handle it anymore. I propose something, and then Daniel proposed something else, and then Andrew look at mine, Daniel alternatives, and says, oh, but this reminds me of this other option, and then John also says, oh, look at those three, actually this reminds me, and this explodes, and you cannot handle this, and nobody could actually handle it. So you need a filter. So anybody can present alternatives if you have a filter. And if you have a filter, you start from this exponential growth of alternatives, and you only keep some. And so this filter need to work all the time, where you get proposals and you filter them out, and you filter them out, and you just keep the best ones. And guess what? The Pareto Front are wonderful as this kind of filters. But how exactly are we going to apply those Pareto Front for the what question? And how exactly are we going to apply those Pareto Front for the how questions? Well, it's 5:54. The lesson is pretty much ended. So I think we are going to look into this at the next time. And so as a homework, I want to give you 4 things to think about. And it's not my fault. Someone says that this was going not to be a lesson, but going to be a workshop. So as a workshop, you should do some work. And it is what represent the what and how questions for DAO, and who should participate at the what and how questions for the DAO. And then how can you apply Pareto Front to manage complexity for what questions, and how can you apply Pareto Front to manage complexity for the first one was for what question, and then for how questions. So I think that next lesson, maybe if we can have 10 minutes to get some of the answers, that would be really good. And you are absolutely allowed to watch my other videos on YouTube until the next presentation, because the answer to at least the last 2 questions are over there, and that would be cheating. Okay. And so I think that if Daniel is fine with this, I think we should stop here.
Sure. Thank you very much, Pietro. Fantastic as always. Thanks again for taking us and the Aragon community through your lessons on using different mathematical concepts and so on for to evolve our thinking and evolve the tools that we are designing. Will you be available to answer a few questions if people have a Discord channel as they work in their homework and so on over the next few days before we schedule your next session?
Yes, except between Tuesday and Thursday of next week. For the rest, yes.
Okay, fantastic.
If anything is in Paris next between Tuesday and Thursday, I will actually give a presentation about artificial intelligence and artificial intelligence moderator, which is what I am actually trying to bring this community eventually to. I mean, all the elements eventually are bringing to this kind of really high. You can use all of them as tools, but putting them all together really. And so, if anybody happens to you might also come to this talk. And I still don't know exactly the day. I don't know. I know the university. So, but ask me on Discord and I'll let you know.
Great, thank you. For those unable to attend, it will be recorded?
It might be recorded, but I will surely do it again for Aragon. So I don't know if it will be recorded. Also because they are paying for all the trip and so on, so I need to ask permission. So, but yeah, probably it will.
Very well. Well, then we will have to wait a little bit until an exclusive presentation for that. So, Pietro, thanks a lot again. For those interested, we'll be scheduling another one of these, maybe a couple of weeks or so. I'll coordinate with Pietro and on as well on Discord. We'll be announcing the dates, and if you haven't subscribed already to the community calendar, you can find it right now on the announcements channel in Discord. I ping it there, And in that calendar, you will see these and other talks and open meetings that we'll be having over the next few days. Once again, thanks a lot, and thank you all for watching this video. I hope you enjoy it, and feel free to send us all your questions on Discord.
Thank you for inviting me.